So guys, ready for the study? We are taking first polynomial chapter. So let's recall our 9th class with some topics. Here is a constant. You know that. Something which does not change its value. For example, natural numbers. You know that all are 1, 2, 3 and so on, and these are all remain same. They never change their values. Then second is the variables, which can change their values for x and y, etc. We know that if we solve x for one question, the value will be changed, and for y for one question, the value will be changed, and for the other question, the values will change. So we call them variables. According to question, they will change their values. So these are non-x and y are just like the variables. Then the algebraic expression. Variable constants joined with mathematical operators like plus, minus, divide, multiply, etc. So just the example is there. This is the example is given 2 plus x. So 2 is the constant here, plus is the operator, and x is the variable. Similarly, x multiply x, that is x square. X is the operator here, mathematical operator. X variable, other x variable is here. So we know that this is the x square. This is an algebraic expression. X upon y. Here x upon its mathematical operator is divide. So this kind of expression, we know that algebraic expression are here. Then we have different type of expressions like the monomial. You know that when we have a single term in the algebraic expression, we call that monomial. When we have two terms in the algebraic expression, that is the binomial. Trinomial, when we have the three terms, here 3x square, x and 1, these are the three terms, so we call that trinomial. Now some special algebraic expressions are called polynomial. We can say an algebraic expression polynomial if this is we express in px is equals a0 plus a1x plus a2x square and so on an x to the power n, where a0, a1, a2, an, these are the constants, and n is a non-negative integer. This is important, this n is a non-negative integer. This expression is called a polynomial in variable x, right? Now the degree, because this chapter we are having here, this based on the degree of the polynomial. The highest degree of x in px here is called the degree of the polynomial. So some example we can see, 4x minus 5 is a polynomial of 1 degree because x is having its power as 1. And second, root 2 tx cube minus 3t square plus 5t minus root 3 is a polynomial in variable t, because we are using the variable t, that is in polynomial in variable t. And the highest degree is here 3. Here t is having power 3, 2, 1. The highest power is 3. So this is of degree 3. Here 5. 5 is a polynomial of degree 0 because there is no variable on a constant. So the degree is 0. Some important thing is there that 5x square minus root x plus 1. X, the power is in fraction. So this is not a polynomial. Similarly, 1 upon, when we take it in the numerator, the power becomes negative somehow. So etc. These are not polynomial. Now we are having types of the polynomials. First is a constant polynomial. Constant polynomial, those polynomials which are having 0 degree are known as constant polynomials. Example is 5, 7 upon 2. There is no variable, so power is 0. So these are known as the constant polynomials. Linear polynomials which are having degree 1, just like 3x plus 5, degree is 1, root 3x plus half, degree is 1. So these are the linear polynomials. Then the quadratic polynomials, 2 degree, 4x square plus 7x minus 3, the highest power is 2. So this is the quadratic polynomial. This is cubic polynomial, 3 degree, those the expressions which are having the 3 degree, just like 5 minus x cube, the highest power is 3. So this is of 3 degree. Y cube, highest power is 3. So this is cubic polynomial. Then we have this biquadratic polynomial. The expressions, the algebraic expression, the polynomials which are having degree 4 are known as biquadratic polynomials. This is 2y4, 3y cube minus 2y square plus 5y minus 8. The highest degree is 4. That's why this is known as biquadratic. Then we have 4 upon 5x to the power 4 minus 8x cube plus x square upon 4 minus root 2x plus 3 upon 5. The highest degree is 4. That's why this is known as the biquadratic polynomial. Now we have to solve the polynomials just like value of a polynomial at a given point. Px 2x square 3x plus 5. This is an example. I can understand the value of the polynomial with the help of this example. Find the value of px at x is equals to 1. The polynomial is 2x square plus 3x plus 5. Find the value of px at x is equals to 1. So we can replace x by 1 here, both the sides. So 2x square is 1 square plus 3 into 1 plus 5. When we solve this, we'll have the value as 10. So this is the value of the polynomial at a given point. The value of polynomial px at point 1. The answer is the value is 10. Now second thing, we are having zeros of a polynomial. Now what is zeros? The value of x in px for which px becomes 0. The value of x in px for which px becomes 0. For example, px x square plus 5x plus 6 at x is equals to minus 2. The value of px when we put x is equals to minus 2 in this polynomial, the value of this, on putting this, we have put it here, p into minus 2 square, 5 into minus 2 plus 6. The answer is what? 0. So we can say that x is equals to minus 2 is a 0 of the polynomial. So what is the zeros? The value of x, that value of x which makes any polynomial 0. So this is the zeros of the polynomial. Now the next thing is there, number of zeros may be less than or equal to degree of the polynomial. This is important. Number of zeros, the answer we'll find for the zeros. The number of zeros may be equals or less than degree of the polynomial. If degree is 4, so the zeros may be 4 or less than 4. Then we have graph of a polynomial with zeros, or we can say the geometric meaning of the zeros. Here the intersection points on x-axis of the given graph are zeros. This is the definition. Repeating, the intersection points on x-axis, the intersection points on x-axis of the given graph are zeros. Means at how many points the graph intersect the x-axis, that is known as the zeros of the graph. Now see, the first example is there, px is equals to 2. So here we can have a table. So px is equals to 2, right? Px and x is 0. If we put here x, no x is on right side. So if we put left side x is equals to 0, the answer will remain same. The answer will be only 2. If we put here 1, again the answer will be 2. If we put minus 1, the answer will be 2. If again we'll put here minus 2, the answer will be 2. If we do the graph here, at any value of x, you will get the value of px as 2. It means the graph will be a straight line parallel to x-axis. It will not intersect x-axis at any point. So px is never is equals to 0 for any value of x. That is, graph does not intersect x-axis at any point So there is no 0 exist. So for this graph, because it not intersect x-axis at any point, so there is no zeros exist, right? Now see the second example, 2x plus 4. So this is linear, x and fx. Here we have taken as fx. So fx is denoting here just y, 2x plus 4. So x is what? 0. The value of x is 0. If we put here, we'll get value of y as 4. If we put here 1, value of y is 6. If we put minus 1, value of fx is 2, minus 2, 0. If we draw the graph, we are having this kind of linear equation. It will intersect x-axis at one point, right? At one point. So this is what? X minus 2. So we can say how many zeros are possible? Only one zeros is possible because the graph is intersecting x-axis at only one point. Then we have fx is equals to x square minus 3x minus 4. This is the quadratic. If we draw the graph for this, we'll get this kind of shape because it's a quadratic graph. There is a table. So this kind of graph will have. Now we can see that the graph is intersecting x-axis at 2 points. One this side and this side. So this U shape is also called as parabola. So how many zeros are possible here? 2 zeros are possible because the graph is intersecting x-axis at 2 points. So ax square plus bx plus c, two types of parabolas can be formed. One is upside and downside. Upside is for when a is greater than 0, means this a is greater than 0 means a is positive. So we have this kind of graph. These three possibilities are there: 2 zeros, 1 zeros and no zeros. Here in this, when this a is negative, so we have this downward type of parabola. There are three cases. Again, 2 zeros, 1 zeros and no zeros. In the last one, it is not intersecting the x-axis at any point. So these are the possibilities and this is the topic. So this is the assignment for you from the NCERT book. Example number 1 and exercise 2.1 you have to complete. Then we will take the next video. Thank you so much.